Welcome to today's physics class. In today's physics class, I want to teach us how to derive the equations of motion. So these equations are also called the kinematic equations of uniformly accelerated body. Now, we start by looking at some various quantities that are so important when we are discussing about motion. So you must not forget speed. Speed is one of those quantities. And speed is measured by what? Distance over time. And the unit of this speed is meter per second. That's the unit. Now, the next one is velocity. Velocity is equal to displacement. The measure of displacement, the change of displacement with respect to time, all over time. Then the unit is also meter per what? Seconds. Another one we are going to look at is acceleration. Acceleration. Acceleration is defined as increasing change of velocity or change in velocity, increasing change of velocity all over time. And the SI unit of this acceleration is meter per second squared. Now, look at speed and velocity. So in dealing with motion, most of them, in fact, the two of them are used interchangeably. Why? Because they are having the same SI unit. In most cases, in place of velocity, we can replace it with what? Speed. So don't be confused when you are seeing speed in some calculations and you see velocity in other. Don't be confused. Though this one is a scalar and this one is a vector, in the sense that, well, this has both the magnitude and direction, and this does not. So let us look at from the definition of average speed. Average speed. From the definition of average speed is equal to total distance over time taken. Okay. And this total distance is represented by S. Okay. Then let us get this our total distance. Let's make it solid a formula. Just cross multiply. So we have total distance S equal to average speed or velocity times your time. And now, of course, in mathematics, when we talk about average, it means we are dividing by 2. Or no matter the quantities, you just add up everything and divide by the number of what? Outcomes. So what you have now becomes, if the objects have initial velocity, which is u, plus we have that of what? Final velocity, v, and this is initial velocity. So the average will be what? Final velocity plus initial velocity, then divided by 2, multiply by time, multiply by t. So that is your total distance. So this one here is the first equation. This is your equation 1. Now, how do we get other equations? From the definition of acceleration, we are told about change of velocity or change in velocity all over time. And if an object start moving with a velocity u, which is initial velocity, then attain final velocity. So acceleration becomes v minus u all over what? Time. Now let us cross multiply. To cross multiply, we're going to have v minus u equal to at. So from here, let's take this negative u to the other side so that we have v equal to u plus at. So this one here is your equation 2. So this is the second equation of motion. Now let us get equation 3 by coming to substitute v into this equation 1. So in place of v, come and what? Replace it with this. Now let's go. So from that equation 1, we are told our S equal to v plus u all over 2, then multiply by what? T. Okay. Multiply t. Okay. Now, we are going to replace this v by what? U plus at. Then, we are already having u here plus u. Remember, This can be factored out to become 1 over 2. Then we multiply by t. This is your t. Now let us write it. Become u plus u here is 2u, then plus at, then multiplying by t, everything over 2. Now distribute the t to both sides, becomes 2ut plus at squared, everything over 2. Now we are going to distribute 2 to both of them, distribute 2 to that. This, so s becomes 2ut all over 2 plus at squared all over 2. These two will cancel these two, so that we now have ut plus half at squared. So your equation 2 or equation 3 become s, total distance, which is for ut plus half at squared. This is your equation 3. Now, let us get equation 4. How do we get equation 4? From that definition of acceleration, so from that equation 2, let us make t the surrogate of formula so that we can come here and substitute for t. And we know that what? V equal to what? U plus at. Now, making t surrogate of formula becomes v minus u equal to what? At. Divide both sides by a so that we can have t equal to what? V minus u all over a. So we are going to plug this one for t here. So that in that case, we'll have s equal to v plus u all over 2. In place of this t, we are going to put this v minus u over a. Put it for t, because we said t is equal to this. So multiply by what? V minus u all over a. Now, let us evaluate. Becomes v plus u, then v minus u, everything. 2 times a becomes 2a. Now, in mathematics, whenever you have something like this, it becomes difference of 2 square, such as x square minus y square. So we are coming here, then let us cross multiply so that we can now have v squared minus u squared equal to 2as. So from here, let us make this one sort of formula. Take this negative u squared to the other side. We have v squared equal to u squared plus 2as. So this is your equation 4. So this is how we derived all the equations. Now let us put all of them together in one place. So this is s equal to v plus u all over 2 multiplying t. This is your equation 1. The second one says v equal to u plus at. This is your equation 2. The second one says s equal to ut plus half at squared. This is your equation 3. Then the last one says v squared equal to u squared plus 2as. This is your equation 4. These are the 4 equations of motion. Now, how do you know which of the equations to use when solving problems? So it depends on the quantity that is given to you, which of the parameters. Sometimes you may be given distance, you may be given velocity, you may be given acceleration. Now you have to look at the 4 equations. Which of them do you think that contains those parameters? And these formulas are used to calculate total distance. You can calculate total distance here. You can calculate total distance here. And as well, you can also get the distance from here. So in my next video, I will bring some questions that we can make use of these equations. So I want you to stay tuned. If you find this class very interesting, please help us to share this video and do well to also like and comment. Bye.